Okay, the post for this question asked for an example and some techniques for finding information related to a rational function. So here's an example. F of x equals polynomial negative x squared minus x plus 6 over the polynomial x squared plus 3x minus 4. Here's a list of steps that you can follow. These steps do not include any calculus, which we can apply calculus at some point in time to find out more information about the graph. But let's just follow these. To find the x-intercepts, we want to know when y equals 0. When does this equal 0? Well, it equals 0 only when the numerator equals 0. And oh, by the way, anytime you're going to graph a rational function, you should factor the numerator completely, factor the denominator completely. That'll help you see if there's any holes. If any of these binomial factors cancel out, you've got a hole in the graph. This one doesn't. But now we can set this numerator equal to 0 to find the x-intercepts. That tells you that y equals 0 and x is negative 3 or 2. So these are the x-intercepts right here. That's where the graph crosses the x-axis. Find the real zeros of the denominator, because that tells you where the vertical asymptotes are, because you cannot divide by 0. So this denominator is equal to 0 when x equals negative 4 or x equals 1. These are your vertical asymptotes. Y-intercept's kind of easy. Just put 0 in for x and find the y value. That's easier to use the f of x, because these factors, or these terms rather, all become 0 if you put 0 in for x. So the y-intercept is at negative 3/2. There's the y-intercept. Now, problem number 4 says apply the theorem on horizontal asymptotes. What does that mean? Well, if the degree of the numerator equals the degree of the denominator, then the coefficient of the highest degree terms, the coefficients of the highest degree terms determine the horizontal asymptote. If the degree of the denominator is greater than the degree of the numerator, then the horizontal asymptote is y equals 0. And if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. So in this case, the degrees are both 2, so negative 1 is the horizontal asymptote. Y equals negative 1. And here's something that's not often addressed in some of the textbooks. You want to determine, does the function ever cross its horizontal asymptote? So that means, does this function right here ever equal negative 1? And if we multiply both sides by this denominator, this is the equation we get. The x squareds, the negative x squareds cancel out. We get 2x equals negative 2, x equals negative 1. So when x is negative 1, we do cross the horizontal asymptote. So there's the point where the graph crosses its horizontal asymptote, the only point. So what have we got? Here's the x-axis. Here's the y-axis. Here are the two roots, negative 3, 0 and 2, 0. Here's the horizontal asymptote. Here are the vertical asymptotes, the green dashed lines. The red dot is the y-intercept. And to help us graph this, I also found the point where x equals negative 5. I actually used the g function by putting negative 5 in for x in all of these places. And there's the point right there, negative 5, negative 7/3. Now, how does that help us? Well, there's only one point where the graph crosses its horizontal asymptote, right there. Okay, a graph can never cross its vertical asymptotes. So that means the branch to the left of this vertical asymptote has to look something like this. It's got to go through that f of negative 5. And it's got to get closer and closer to its vertical asymptote and its horizontal asymptote. It can't be up in here, because to get to this point, it would have to cross the horizontal asymptote, and it can't. And then in this, between the horizontal asymptotes, we've got to go through these 3 points. We can't go cross back over the horizontal asymptote. So a rough sketch for the curve between the vertical asymptotes might look something like this. Whoop, and I got a little sloppy there. And then finally, for the curve, the branch of the curve to the right of this right vertical asymptote, it's got to look something like that. We got to go through that point. We can't cross the horizontal asymptote. So it's got to look something like that. Okay. That's the basic idea. Now there's other things you can do, like algebraically finding the range of this function. It's fairly complicated for this problem, but if you look at your sketch, you can see that the graph apparently crosses every y value because of this center branch right here. There's no places where the graph does not hit a particular y value. Okay, there you go. I'll post a link to the Desmos graph where these functions are plotted. If you have any questions, post a comment.